Thank you all for joining us this morning. We are starting the second day of the conference. The first presentation will be from Sergey. Sergey will be talking about bridging type systems. And yeah, so it doesn't echo. Yeah. Okay.
Okay.
Yeah.
I can't talk, but can you hear me? Yay, finally. Great. All right. Let me finally start then. Hello and welcome to my talk, which is about type systems and bindings in the context of C++. It was actually supposed to be an in-person talk, but sadly, I have to present remotely, and there are technical issues we've just faced, which is not great. Okay, so a tiny bit about myself. I'm Sergey. I hack on various projects, including glibc, SRNTOS, and I've been using GNOME for about 10 years by this point. And recently, I've been hacking on GTK, including layout things, and glib for bindings. And I'm proficient in a bunch of languages, some of which are listed on this slide. So this talk is about C++. Why should we care about C++? Well, C++ doesn't get a lot of mindshare in the GNOME community, but actually it's one of the most popular programming languages out there. And there is a ton of software written in it. Here are some logos. And of course, if you're going to be writing an application which uses a library, if the library is written in C++, if its API is in C++, naturally, you're going to want to write the app itself in C++ as well. It only makes sense. Then, on top of that, the main alternative to GTK, Qt for the Linux and cross-platform experience, and Microsoft's MFC and the broader Visual C++ offering. There are both C++ as well, which means that actually C++ is quite popular among desktop app developers, and yet we sort of failed to present a compelling developer experience for those developers. We failed to attract them to GTK. And on top of that, well, C++ is mostly a superset of C, which means that developers who choose to use C++ instead of C, they don't expect to lose any performance or expressiveness by choosing to use C++. Now, in the GNOME world, it's a classic choice for being able to use GTK and related libraries from C++ has been the venerable GTK-mem project. And I'm going to be criticizing GTK-mem a bit in this talk. So I want to start by saying that GTK-mem is actually great. It enables people to indeed use GTK from C++ in a way that feels very natural and native to C++, and that's great. And it has enabled all of these applications and more, so System Monitor, Transmission, Inkscape, which our designers use to craft the beautiful icons and apparently now presentations as well, and others. That being said, GTK-mem has been designed in a different era. I've been able to trace its history back to 1998 or so. So it's about as old as GTK Plus itself. Notably, it predates GEAR by a decade. And GEAR is, of course, our XML-based structured format for describing APIs in a machine-readable way. And it predates composite template widgets by a few more years. And I'll mention why that is in a second, why that is relevant. Now, when you write your code using GObject, it oftentimes feels that grass is always greener on the other side. What I mean is you have a choice. You either write your code in plain C, in which case there is a lot of boilerplate for you to deal with, or you can write in a higher level language. But there are downsides to both of these. So imagine you're actually writing in plain C, and what you want to do is you want to add a new property to your widget, which when set would cause the widget to resize. And the way you might visualize it in your head is somewhat like this. All right, so a string label, which on set calls self-QResize. But what you actually have to write is more like this. You add a field to your instance structure. You free it in your finalizer. You add a new member to the enumeration. You create a param spec. You install it. Then you go into your header and you declare the getter and the setter with the availability macros. You implement the getter, which just returns the fields. You implement the setter. And here we're actually lucky because we can use gset_str, which is only available if you have new enough glib. If not, you're going to have to deal with more boilerplate still. Then you call GTK widget key resize, which is the only actual thing that you wanted to do in the first place. And then you will have to add a new case to your get property and set property functions and deal with gvalue to extract and set the string. So that's quite a bit of boilerplate. It might seem okay if you're a seasoned GTK developer who's just used to this kind of thing, but that's exactly because you're not thinking in terms of the C code that you have to write. You're visualizing it in your head as just adding another property. Try convincing a newcomer that this is actually a superior way to structure their code, as opposed to just not using GObject at all. Now, the alternative, of course, is to just use a higher level programming language, like, say, Python or C++, in which case there is a lot less boilerplate. You have all of this nice syntax sugar. On the other hand, you're facing all of these challenges constantly. Can I have a class init function? Can I initialize my type before class init gets called, such as to call GIO extension point implement? Can I have an actual proper per type instance initializer, which doesn't override the version from the base class and instead is attached to the type? Can I put my data into the class structure? Can I have and override static virtual methods? Can I directly accept property specs? And can I notify a property outside of its setter? Can I have construct-only properties? Can an instance of my class be properly constructed by calling GObject new? Can I even weakly reference a GObject? And while well, the answer may be yes to some of this, more often than no, it's no, you cannot. So this might all be fine if what you're trying to do is just write code in your language and only interact with GObject tangentially. But if you're actually trying to write GObject in that language, you're constantly hitting against these limitations. Now, modern best practices of GTK development have been formed over the last few years. They revolve around composing template widgets, which implies GTK builder, and also there are list models, expressions to be used with GTK builder, list, item factory, actions, CSS, and more. And what these features imply is that you have to use the dynamic features of the GObject type system, even when writing in a static language like C++. So if you are using a dynamic language like Python, for instance, it makes sense that Python resolves everything at runtime by name anyway, so it would use dynamic features of GObject. But in C++, you would think that you can get away with only doing things statically and not caring about all the dynamism. But if you want to use GTK builder, if you want to use properties and signals, you cannot get away from it. You should still properly support all of the dynamic features, such as specifically having instance initializers, class initializers, being able to properly instantiate your object via GObject new, having real properties that you can get and set via GObject APIs, being able to notify of those property changes, being able to connect signals. In case of GTK-MM, it implements signals with something separate called libseq C++, which is a separate implementation of signals, which has nothing to do with glib. So glib signals are bridged one way to libseq C++ signals, but not the other way. And you want to be able to implement interfaces, such as glist model. And yeah, so GTK-MM supports some of this. For instance, you can, in fact, implement interfaces, but not many others. And then there are some stranger things about GTK-MM. For instance, there is something called GTK-object, which might have been a thing in GTK plus 2 times, but somehow it's still there in GTK-MM 4.0. Similarly, there's something called glib object base, which is unclear. Then, when you create an instance using GTK-MM, such as, for instance, by calling GTK button create, what you get back is actually an instance of a private subclass whose name is GTK-mem under GTK button. And that's fine. What's worse is that when you derive a custom class, such as your own widget, well, GTK-mem has you specify your desired class name as a string, which is again fine. But what it then does is it prefixes the string that you give it with GTK-mem under custom object under. And that's what your final class name is. Not only that shows up in the inspector, that's actually what you have to put everywhere that you mention your class, for instance, in a UI file. That looks quite ugly, and honestly, just why do that? Why punish me for trying to use GObject the way that it was designed to be used? Then graphene, the geometry primitives library, for some reason shows up under the GTK namespace. Then there is something called glib ref pointer, which is actually an alias to std shared pointer, but it shows up in a lot of unexpected places. For instance, in this snapshot function, as we all know, it actually takes just a plain reference to a snapshot without any ownership transfer. But in GTK-mem, it for some reason accepts a constant reference to a ref pointer to a snapshot. So these are just weird and barely explicable. But that's all relatively minor. What's more complex is this, as memory management situation. So GTK-mem, it does what many other bindings do, in that it has two separate objects. The real GObject is on a heap, and there is a C++ wrapper that GTK-mem makes for it. And the wrapper has a direct pointer to the GObject that it wraps. That makes sense. And the GObject has a back pointer to the wrapper using the QData mechanism. And this, of course, creates a reference cycle. And that could be problematic, but fortunately, GObject has a way to deal with those toggle references, which GTK-mem does not use. It partly has to do with the fact that, well, the GObject itself, it's heap located and reference counted. The wrapper is not necessarily, and in fact, GTK-mem encourages you to stack locate it or put it in a field in your composite widget. And that, of course, means that their life cycles become detached and can get out of sync. The wrapper can get deallocated before the object it wraps. And then perhaps if you get another reference to the same object through some other API, it might create a second wrapper for the same object or something. And that is a mess. And they know it. And there are some hacks inside GTK-mem to try to make this less bad. For instance, they have to, for some reason that I don't understand, inject some logic into the widget hide callback in order to handle the case of the wrapper going away at the same time. But what's worse is this dispose callback that they do. For one thing, they don't let you actually override the func dispose. They have their own version. And starts with avoid disposal, which is already foreshadowing. And then it says abort dispose if the widget isn't managed in order to prevent the nasty self-destroying behavior of GTK+. And then if you look at what it does, it actually tries to unparent the widget, which is honestly horrifying, because if you know anything about GTK, you know that a widget cannot unparent itself. It's only its parent which can do that while updating its own internal state. Yeah, so once I saw that, I decided that I don't want this logic anywhere near my widgets. And generally, I don't think that language bindings are in any position to do something like that. They should expose the existing APIs to the language and not do much beyond that. They shouldn't inject their own logic. They shouldn't even know what a widget is. That's not something that language binding is supposed to do. There are exceptions, of course. For instance, yes, we want language bindings to enable one to use composite widget templates nicely. But yeah, this is not one of those exceptions. This is a horrible hack, and I don't want this to get used. And then there are some C++ design principles. Most famously, the zero overhead principle, which says what you don't use, you don't pay for, and what you do use, you couldn't implement yourself any better. And I feel that GTK well, basically violates that, because you can, well, you are in fact paying for what you don't use. You are paying for all of these wrappers to get created and destroyed and tracked. And you can totally implement things better and more efficiently if you just call the C function directly, avoiding GTK. Then it says provide as good support for the user-defined types as for built-in types. And again, this is absolutely not the case with GTK because built-in types, namely ones that are implemented in C, in GTK, they have full access to all of the GObject and do everything properly, whereas user-defined types are severely limited. And the third one is leave no room for a lower level language below C++, not counts in the assembly. And again, this is not true at all, because after banging your head against GTK for like hours and days, you finally give up and you rewrite your widget in plain C. And yes, you have to write a lot more boilerplate, which you're fine with by that point. But at least you get full access to everything you wanted to do. You can actually have a class in it. You can actually have normal properties and so on. So yes, there is absolutely room for a lower level language below C++ with GTK. Now let's look at something completely different. This is Vala. Now Vala, of course, has its own share of issues. As a Vala compiler contributor, I would know. But here's my point. When you write GTK button in Vala, that's not some Vala under GTK button wrapper structure. That's an actual GTK button pointer. When you write new GTK label in Vala, that's not some wrapper being created. This is just a GTK label new call. So Vala is not a separate runtime wrapper library. It's really just nicer syntax for the very same code you would write in plain C. Yes, I really want to emphasize this difference in approaches here. GTK is a C++ library which wraps GTK, and Vala is just nicer syntax for the very same C GObject code that we would write in plain C. And actually, there is another instance of this. That's how Swift lets one import plain C and Objective-C libraries and use them from Swift with somewhat nice syntax. And it too doesn't create any runtime wrappers and just calls the C functions directly. With that being said, C++ does have a bunch of attractive language features, so we shouldn't give up on it. There are closures, there is automatic resource management, a powerful type system, and so on. So the question then becomes, can we make use of these C++ language features to improve our experience writing GObject code, so without giving up on GObject? Can we have the best of both worlds? Can we basically take the Vala approach and implement it using C++ language features? And well, of course, I believe the answer is yes. While at it, we might as well fix miscellaneous GTK annoyances, which is, first of all, poor API coverage. This is partly due to the fact that they don't use gear. They use a custom API description format, which has to be manually kept up to date, which takes a lot of maintenance work. And for instance, they've only recently started adding the first bits of GSK wrappers. And secondly, due to the fact that they attempt to keep a stable C++ ABI, which, for instance, prevents them from adding new virtual methods to the GTK widget class. As you've seen, they clutter the glib namespace, which they unknowingly spell with a lowercase l. They require C++ 17 in the latest version, which severely limits which systems you can deploy to, and it's hard to set up. It might be fine if you're just installing GTK from your system's package manager. It's a lot harder to build it from scratch, doubly so in Windows. If you try to build GTK on Windows, you know my pain. While the rest of the platform is all built with Meson, all the way from libadwaita down to glib with side quests in the form of things like font config and harfbuzz and libgpeg turbo. It all can be built with Maven. It all can be used as a sub-project. And yet GCK-MM is its own special thing with a build system based on Perl, which shells out the Unix utilities which are not present in Windows. It is possible, but it is hard. So with that, let me introduce my project. The name is Peel. Here's what it looks like. This is some C++ code, which creates a window with a button, and it does much of the same thing as the C code. Yeah, you can see they are quite similar. And actually, this compile to practically the same machine code. So that's what I mean when I say no runtime overhead. This is the same thing, except using the C++ syntax. And actually, if you've been using GTK-MM, you can notice that it looks very similar to that. So that's interesting. These are two very different approaches, as I've shown. They start from different foundations, different ideas, and yet they nicely meet in the middle, and the resulting code, which uses GTK-MM, and code which uses Peel, they look quite similar. Yeah. Now let's look at some actually tiny little bit of Peel, which is not that groundbreaking and so on, but it again can be used to nicely illustrate the concepts. That's a ref pointer. That's a smart pointer type, which wraps just a pointer. It refs it when constructed, it unwraps it when destructed. You might use it like this. Assign a pointer, it calls GObject ref, do something, it goes out of scope, it calls GObject unref on it. Alternatively, you might move it to the call. This is like calling just a pointer. So the pointer is nullified, and there won't be an unref call. And this is nicely aligned both with C++ move semantics and with the usual C GObject patterns. And if you look at the produced machine code, we can see that it has direct calls to the C functions. So the whole ref pointer type got inlined, and you get much the same code as you would if you call this in C yourself. Well, ref pointer shares the name with GCK-MM's glib ref pointer, but unlike the shared pointer, which adds its own layer of reference counting around the type, ref pointer is designed to work with an existing reference counting mechanisms inside of the type, such as one in GObject, but it can be used with more than just GObject subclasses. So for instance, if you do a ref pointer of a glib hash table, it will call ghash table ref and unref for you. This way, the C++ code that uses these types, it stays uniform. It just says ref pointer, and Peel calls the right memory management functions in the background. It can also be compared to GAuto pointer, and this is where the difference really becomes apparent. First of all, GAuto pointer is of course based on GCC extension, whereas ref pointer is just standard C++. Secondly, GAuto pointer simply calls unref once and goes out of scope. It won't actually reference when a pointer is assigned to it, and it won't unreference the old value. So if you have a loop like this, you're going to have a leak, whereas ref pointer, it does the right thing in basically any way that you try to use it. It inserts references and unreference whenever needed. So basically, memory management is not a concern when using Peel. Now let's look at some actual classes. This is a label which derives from widget, and we have a select region method. And the way that it's implemented is simply by casting this pointer to the C GCK label type, and then forwarding the call to the C function. And it's inline, so the compiler will inline this call, and you'll get a direct call to the C function. And similarly, here's GTK widget gets CSS name. Again, we just cast this to the C type and forward to the C function. And here's how you might call it using the C++ method call syntax. As you can see, it is possible to call the widget method on label because it inherits from label from widget. without any syntactical or runtime overhead, because C++ allows that. And again, as you can see, from us being able to cast this to the C type, this is not a separate runtime wrapper object. This is just a C++ view of the same class. Now, of course, those two were rather simple in their signature. Here's a more interesting version. We have jinput stream read all. I won't show the implementation, but it too consists of various casts around the C call. We pass in an array, which is actually an out coder allocates array. We have an implicit count argument. Bytes read is an out argument. Cancelable is an in nullable argument. An error is out, and it's uniquely owned, so it's returned by unique pointer, which is another kind of smart pointer in PIL. In this case, it will call gerror-free when it goes out of scope. ArrayRef is just a way to conveniently pass arrays in various ways, including when you pass in a C array, it will infer the size for you. And it can be iterated over using a for loop, and it does other idiomatic C++ things. Here's yet another example. This is maplist model create, which accepts a model to wrap and a mapper function. And since both the argument and the return value are transfer full, so ownership is transferred, in the PIL signature, it accepts a ref pointer, which means that you can either move an existing reference into the call, or you can pass a plain pointer, in which case PIL will do a GObject ref call on it. And similarly, you get back a ref pointer which owns a reference, so you can use it, and it will call GObject on ref when it goes out of scope. The lambda is actually 3 arguments in C. That's well, the callback, the user data, and the destroy. In C++, you can pass an arbitrary callable thing. Most typically, it will be a lambda. Here's an example. We move in a model pointer, and we pass a lambda, which captures something called address book for this example, which it uses to look things up. As for closures, well, in this case, we have indeed captured a single thing called address book, just a pointer. So what PIL will attempt to do is it will pack that closure data right into the user data pointer. It can do that when what you capture is pointer sized, and when the lambda doesn't modify the capture data, which is true in this case. If it cannot do that, it would do what you, again, would typically manually do in C. You do separate closure, you heap allocate it, you pass it the heap pointer as user data, and then you have a callback which carefully tears it down. And again, PIL will do either one or the other automatically, depending on whether or not what your lambda captures fits into a pointer or not. Let's briefly look at custom classes. Here we define a button which inherits from widget. We have to use a simple macro, which is like JDeclare type. We're going to have dispose. In a CPP file, we use another macro, which is more like JDefine type. We provide the name as a string with no ugly prefixes appended to it. We can have a class init in which we override dispose, and we can call some class methods. Again, since in this context, the C++ this is actually the cool button class, we can call GTK widget class methods with this convenient syntax without any syntactic overhead. Here's dispose. We unparent the child if you have it. We're going to look at child in a second. And then we chain up to the parent dispose. So you can see that vfuncs, they don't become C++ function point, C++ virtual functions. Instead, we keep them GObject style. Let's set a child. We just put a pointer into a class, and we define a getter and a setter for it. That's just pretty standard C++ stuff, nothing GObject specific about it. Pay no attention to the float pointer. And then we use the PIL property macro to actually declare that we have a property. And then we do this. Define properties is used to link the property that we've declared to its getter and its setter. And this is also where you'd configure other things about the property, such as its nick and additional flags, if you want to. And this is actually a really nifty design. This is a combination of a builder pattern, like you'd have in Rust, with X macros from C, except that it's not implemented with C preprocessor macros. It's implemented with C++ templates. So this function, in fact, becomes the body of get property and set property. And it's also injected into the class init to actually install those properties. And again, if you look at the generated code for get property and set property and class init, it does look much like what you do manually in C, so there is no overhead for this. Once we complete a class, we can create an instance of it with just object create, also known as GObject new. And then we can immediately call both imported C methods, like in this case, get type name, which is a type instance method, our C++ methods, like setChild, and we can use this button instance anywhere that a widget is needed, such as in the Windows setChild call. It all fits together and our button shows up. Well, of course, this is a very simple example, but PIL has been successfully used in large commercial projects which are already shipping. So it is scalable to complex tasks as well. Yeah, so here's PIL. It's based on Gear. Basically, PIL largely consists of bindings automatically generated from Gear by a generator. The generator is rather easy to run. You can do so yourself. And in fact, we recommend that you run the generator as a part of your project's build system to generate bindings that your project is going to use at the time of your project's build. You can generate bindings for like an experimental version of GTK or libad beta. You can use new features as soon as they appear. You can generate bindings for a private library, one that you never published anywhere, or one that's internal to your project. So you don't have to upload bindings to some sort of central binding repository or wait for a new version to come out. You can just use whichever API you want as soon as the API appears with the Gear description. PIL is designed to be zero cost, meaning no runtime overhead whatsoever. It does that partly by being fully inlineable. It's a header-only library, so there is no repeal.so to link against. You just include a bunch of headers. It is easy to set up. The generator is written in pure Python with no external dependencies, so much like Maven, which means that it should be able to run anywhere that Maven runs, and it is possible to pull it as a Maven subproject. It only requires C++ 11, which is widely available, and it fully and faithfully exposes GObject concepts where possible. Now, I'm afraid I'm a bit out of time, so let's look at this slide and then skip the rest. Library developers, please write bindable APIs. There is a great post by Emanuele, which goes into a lot more details about what that entails. Please follow the link or just Google for this name and follow the advice. That would help us binding developers a lot. Please learn about what GObject introspection annotations mean and apply them consistently. Please do check your Gear. Gear is not just some opaque XML that gets generated by an obscure tool at build time. It is actually a real direct description of your API. So you should look at it and compare it against your idea of your API and check if they match. There is a lot of broken Gear out there in everything, including GTK and glib, that I had to work around. Doubly so in GStreamer. And do look at your APIs through bindings. For instance, if you add a new function, try to call it from Python. See if it works. See if it works like you'd expect. If it doesn't, probably your Gear is broken, so you're missing some sort of annotation somewhere. And then I have a bunch of advice to binding developers. So use Gear. In 2025, there's really not any reason not to. Handle various cases of arguments, including arrays. Please pay attention to non-object derived types, including box types and type instances. PyGObject, our Python bindings, has only recently added support for non-object derived types, which is great, except that it only partially works. Here's an example. We might create a render node, and when it gets out of scope, the whole process crashes. Amazing. Please support custom classes. Please consider what to do about reference cycles in closures, particularly, again, in composite widgets. Please make FFI straightforward, so have a way to extract a C pointer from your wrapper and to reify a C pointer back into your wrapper. And consider integrating dbus support based on GDBus, even if your language already has a different implementation of the dbus library. If a language is natively compiled, deals with memory directly, like C++ or Zeek or something, do expose real objects instead of wrappers, do pointer conversions without runtime overhead, do model ownership in the type system. This is what Pil does for C++. You can do the same in your language, probably. If your language is more garbage collected, self-pointer, scripting like, say, JavaScript, then you have to do this two-object approach with a wrapper and a real object pointing to each other. That's fine. Do use toggle references. Do make sure that basically you can successfully initialize an object from either side. So either using your language's native syntax for creating objects, or by calling the object new on the type. And avoid unnecessarily raising the funcs too. Finally, if your language is more like Haskell, it has no object identity, it is value-based, then there is an issue in that if you have a custom class and try to attach some data to it, and then you upcast it to GDK widget, for instance, you sort of lose that custom data, custom state. So the solution would be take a book out of GCKRS, take a page out of GCKRS book, and separate the representation of the widget itself from its state. This way you can upcast the widget representation or downcast it without losing anything, and the state is just a bunch of data, which is not an object. That's it from me. Thanks for listening. If there is any time, I'll be happy to answer questions. And here's the Pil repo. All right, thank you.
Hello everyone and welcome back to GUADEC, day 2, track 2. We are going to continue with our next speaker. I don't know if you can all hear me well in the room and online. All good? Okay. Oh, it's off. It's off. Hello, hello. 1, 2, 3. So let's build an openQA test suite from scratch.
Yeah.
Perfect.
That's the one.
I got so used to introducing people in track 1 that yesterday I introduced someone from track 1 at the same time. I was like, there were 2 speakers. I was like, Matthias Klasse, like JTK, that thing.
They both had like the same talk name though, right? Every talk is like the state of.
Yeah.
You should call this the state of openQA.
Totally off topic, and they were like, huh? When I saw the name of, like the name of someone that I knew was here, and I had 2 people online, I was like, something's not right.
Test.
Oh, double, better double check.
Test.
Anisa?
Test. 1, 2, 3. Io sento che qui in stanza si sente proprio bene, cioè nel senso è acceso.
Sa.
Test.
Test.
Okay, so I don't know, I can share an experience, tell a story, tell a joke. I don't know many jokes, but I can try.
What's been the
It's not going to be
highlight?
very funny. Yeah,
Been your
I
highlight
can
of
fail,
GUADEC so
yeah.
far?
Yeah, my highlight in GUADEC, I haven't attended any talks apart of the ones that I moderated, and I was so worried about the time that I didn't really listen to what they said, so maybe the both days. Sorry. Hello?
Yeah, it's working though, it's just the volume is quiet.
1, 2, 3. 1, 2, 3.
Yeah, it's working.
Yeah.
So it's the volume.
Shall I put it in this thing?
In here, I receive it properly. Just in the room, that was okay. Well, I'm okay to shout. Everyone can hear me now. Okay. Well, yeah, there we go. I just need to be near the microphone then. Okay, let's put it here. Put it here.
Yeah.
And I will lean over like a professional radio announcer. Okay, ladies and gentlemen, I hope you're sitting comfortably. Prepare yourselves for the journey.
Okay, Shazwan is saying that he can hear me wanting to make jokes on stream.
Okay, you tell a joke and then I will start.
He's like, you're failing, but try.
Okay. All good? All good? All right. Shall I go?
Feel free to introduce yourself.
Okay. Hello. I'm Sam. Thank you very much for coming. This is a talk about my favorite testing tool. So the thing I love in GNOME, right, is we like to do things properly. But if you... you see, even the videos, we like to do them properly. But if you're testing a platform, some bits of it are quite hard to test, right? Like GDM. How many unit tests does GDM have? What's the unit test coverage?
3% test coverage.
Perfect. So I'm going to show you a test tool which can test anything. You can follow along if you're feeling active. You're welcome to clone this Git repo, scan the QR code, and you can do some of the stuff that I'm doing. So it's gitlab.gnome.org, Thursfield, and then sam, which is my IRC name, _openQA. More about that later. So some quick facts about openQA. I've done talks before on why you should use it. I'm not going to do that again. You can test anything with it. This is a photo, this is a screenshot from the Debian installer team's test suite, in which they take a Windows machine, Windows VM, install Debian, and then check that Windows still boots. So it's not even just for Linux, right? You can test anything in openQA. Several downstreams are using it today. OpenSUSE are using it, and they created it. Debian are using it. Fedora are using it, and some other distros. We've used it in industry, in CodeThink. And we use it in GNOME OS, right? Although we need a bit of help to maintain the tests, so we need funding, really, for someone to maintain the tests. But we use it in GNOME OS as well. However, I lied a bit. I'm not going to tell you anything about openQA. So openQA is a test orchestration tool, and it's like a front end for a tool called ISO to video, or OS AutoInst. And as you can see in the diagram, openQA is like a web application which runs, on a server, and it has a series of workers. And when you run a test in openQA, one of the workers picks up the test and starts a process named OS AutoInst, or IS, which then calls ISO to video. That's the thing that reads the tests, and that's the thing that runs them in QEMU and turns the output into a video, hence ISO to video. So we're going to look at that today. It's got two interesting features. One is that it can run the tests in a virtual machine, so it's great for testing low-level or hard-to-reach stuff. And it also has helpers for testing graphical interfaces. So what about virtual machines? Virtual machines are a way to run another operating system within your computer. It's very common if you work on the kernels or if you work on systemd or something like that, because you don't want to install systemd into /user. Nobody does that, right? Nobody does that too often. So instead, you'd run a virtual machine. We can run GNOME OS in a virtual machine, and we're going to do that later, but it's like a 4 GB image, right? It's a modern desktop OS, so it's not small. 2 GB now. Oh yeah, we've had some good initiatives recently to slim it down, but it still takes a few seconds to boot. So I'm going to start with a really minimal OS that I made using Buildroot, which is less than 10 megabytes in size. And this is where we go into terminal land and we start playing with it. So here we go. This is a full operating system in 8 megabytes. It has a kernel, BusyBox, and a couple of frame buffer test programs. And just to get started, I'm going to run it in QEMU on my laptop. So this is QEMU. If you've not used it before, it's very powerful, and the command line arguments are quite complex. So don't try to memorize how the QEMU command line works. Find one that works and copy it. So save it in a shell script and just run it that way. This is a pretty standard configuration, like 100 megabytes of RAM, modern PC, uses the same CPU as your host, uses KVM, which is hardware accelerated virtualization, so it's very fast, uses a very old VGA driver for reasons I won't go into, and this is the most interesting thing. This is a VirtIO console. So let me run, as you can see, this is adding a CD-ROM, that's the Buildroot ISO. And there we go, I booted an operating system in like 1 second. Here's a graphical console. Don't ask about the frame buffer corruption, that's because it's the Cirrus VGA driver. But this is a working Linux machine. I can log in, run commands. I can run my frame buffer test program, which is very beautiful. There you go. We can get the party started. But if you're testing, this graphical terminal isn't so useful, right? The graphical console is cool for displaying corrupt text. I can type things here, but I can't copy and paste. So what's a lot more useful is the hypervisor console, which is text only. And, oh yeah, I'm in tmux. This is running in my terminal. So QEMU is outputting a special console as text into my console. And look, I can copy. I can log in, I can run commands, I can copy them to the clipboard, I can check the output. And then if you've never used this before, the magic key is Control-A, so Control-A question mark. If you're running this yourself and you want to exit, Control-A-X. Did that work? That didn't work. Okay. So that's how we run virtual machines in 5 minutes. Remember the thing about graphical consoles and text consoles, because that's going to be important. So if you want to do automated tests of operating systems, one thing you can do is you can just write scripts that run QEMU and talk to it over the VirtIO console. And people do that. If you look at Free Desktop SDK has some VM images built in. And every time they're built in CI, it runs a CI job that starts the VM in QEMU, runs uname and checks that the machine gave like meaningful output. So this is, an actual CI job from Free Desktop SDK CI. And if you're just doing a few shell commands, stay with that, right? You don't need all of OS Auto Inst and ISO to video. But if you want to do graphical testing, then read on. So ISO to video is not much more complicated to write a basic test. This is a fully working test, which, if you look in the run function, we select the VirtIO terminal, we run a shell command, and then a search script run will consider the test passed if the command returns 0 or failed if it returns 1. And the rest of this is a little bit of, let's call it a DSL. So people ask me a lot, openQA, do I have to know Perl? And the answer is no. I don't know Perl. You don't need to know Perl. Consider the test API to be a domain-specific language just for making tests. It looks a little bit like Perl. It acts a little bit like Perl, but don't worry about it. So to run a test in ISO to video, we need not much more than just this test. We need a main entry point, and we need a bit of glue code. So I'm going to show you that. This is actually a fully working, this directory has a fully working minimal test. And this is the main entry point, a little bit of magic. This loads what's called the distribution object. More on that later. We're using a minimal distribution here. This is a couple of globals which tell the glue code how to log into the machine. You can see my root password is very secure. And then this is how we define different test suites. So for the example, we only need one test suite, so I'm going to delete the others. So we have one test suite called minimal test, with one test module called minimal. And then we have a lib directory, which we're not going to look in yet, but that's the glue code that makes this work. Well, we are going to look in it, just to show that I'm not hiding anything. So it was good I looked in there, because I need to stash some changes. Let's see. Or do I? Let's check the test module and see. Yes, I do. Okay, let me get rid of this. I'm spoiling a later part of the talk. So this should do the same as the QEMU demo I just showed you. Should open the machine and log in. And last thing, how do we run ISO to video? My advice is use the container images. Upstream provides container images built from every Git commit. And it is packaged in some distros. But unless you use OpenSUSE, they're probably out of date. So just use the container image, it's easy. It's 2025, everything's a container. Use CPAC if you want. I'm going to use Podman though, and I have a helper script to run ISO to video. Let me go a little bit through what it's doing. So the container image we're using is the openQA worker. And we don't want to run the whole worker, so we just say start ISO to video directly, start the test runner directly. And then the test runner needs an operating system image, so we mount that here. We need some tests, so we mount that in /tests. And then we need the test output. So we mount a folder here called out/minimal test, where the test runner is going to write what happened. And then this is configuration for the test runner. So a couple of these things are obvious, right? We tell it where the OS image is, which is where we mounted it. We enable the VirtIO console. That's very important. And a bit of QEMU config. So, are you ready to run your first ISO to video test? All right. It's the same shell script, no magic. So, I know what happens. I need to delete the test results from the last run first. Okay, this is debug output from the test runner. You can kind of see what it's doing. You don't need to learn to read this. There we go, 5 seconds or so, it's finished. And now we have a bunch of stuff here. The interesting bit of the test output is this JSON file, result minimal. So, most importantly, the test succeeded in 5 seconds. And then these 9 bits of details are logs from every time we made a test API call. So if I did have a way to do this. Yes. Okay, I'm going to cat each one of those. And let's start at the bottom. So wait serial is the thing that reads and writes the text console. And you can see here it ran uname-a, like our test asked us to. And then it printed a tag, and it printed the exit code of the command. So the response we got back from the machine was firstly the output of uname-a, and then the same tag, which is really useful to show that the serial connection isn't corrupted. And then we got the exit code, which was 0, so we know the test succeeded. The rest of this is the glue code logging into the machine, right? Because it has to log in before it can run a command. So there's some fairly simple code that waits for the build root login prompt, types root, types the password, waits for a shell prompt, and then passes over control back to the tests. And there's a couple of other bits of useful test output I could show you. We have the output of the serial console, which has everything the kernel wrote to the serial port. You don't need to know what this means, but if your machine doesn't boot, then it's very useful to have this, because you can go, okay, why didn't my machine boot? You know, it starts with the command line arguments that we pass to the kernel, and it goes on right down to a successful boot. So that's all very well for a test that succeeded. What about a test that fails? Tests are supposed to fail, right? Otherwise, you don't know that they're doing anything useful. So how can I make this test fail? Give me some ideas. Okay, what should I call it? This doesn't exist. Okay, so let's run it again. Okay, and we look in the results minimal file again. Okay, result fail. That's good news. We wanted it to fail. And there's a little bit more details. One thing you haven't seen before, there's a screenshot. So this is a graphical testing tool. So by every time a test fails, it just takes a screenshot for you so you can see what happened. In this case, the screen will be blank because we didn't write anything there yet. And if I look at all these text files again, okay, so we got this doesn't exist, not found, and we got an exit code that was non-zero. So the test failed. Good news. Everything is as we expect it to be. Okay, so that's how you can do shell commands in the machine. And I guess hopefully you're already thinking, like, this is quite powerful. There's a lot of stuff in GNOME that we can test by running dbus calls, for example. Run a dbus call and see what happens. Inject a shell script, which is also possible. Inject a shell script from somewhere, run the shell script, and that does some automated testing. So ISO to video can help you do that if you want to do that in a virtual machine. But where it's really useful, and where I'd recommend it over other tools, is graphical testing. So the way this works is via VNC. VNC is a remote desktop protocol, and QEMU has a display type called VNC. And it doesn't display anything on your screen. What it does is it forwards keyboard and mouse events to the virtual machine as a virtual keyboard and a virtual mouse. And it lets you read back what's on the display. So ISO to video uses this to control the VM, like it uses it to inject keystrokes and read back what's on the screen. And we can also do live debugging, right? So one thing, if you've done a lot of testing in Anger, is that it's hard to get the test right. You don't just write a test and like, oh great, now my test is finished. Often you want to kind of do some interactive testing first. And so QEMU, the VNC display, is really helpful for that. And we can, I'm using the break timer, you can see, but I didn't take my break. That might cause problems later, hopefully not. So what I'm going to do here is we're going to add a long sleep call so the machine just stays running. We also need to extend the timeout because everything when you're doing VM testing needs a timeout, right? Because the machine could have hung. So you always want some timeouts in case the machine hung and you don't want to test wait forever. So the default timeout is not 10 minutes, so I'm changing it to 10 minutes here. And then let's run the tests again. I need to delete the old test results. And meanwhile, I'm going to use a simple VNC viewer. This is from Tiger VNC. That's like the most basic VNC viewer. And I'm going to connect to localhost 5990. And we have to pass the shared flag because I think by default it doesn't want to share with another device. So there we go. There's the VM. And, I can do stuff here. If my test hangs, I can actually open the machine over VNC and start playing with it and see what went wrong. Maybe I'll debug why the Cirrus frame buffer driver renders the fonts terribly. But not now. What I'm going to do now is just turn it off. And look at that. The test failed because if the machine powers off in the middle of the test, that's a problem, right? You want your test to fail. Unless you expected it to happen, in which case you can detect that. So we're getting close to doing a graphical test. Remember what I said about consoles? The virt.io terminal, where we've been running shell commands, is text only. And we're going to need to define a new type of console. So ISO to video has a bunch of different implementations of things it calls consoles. Both the text ones and the graphical ones are called consoles, even though they have different capabilities. So virt.io terminal is the one that we use for text. And we're going to use one called TTY console for talking to the graphical frame buffer over VNC. The multiple backends thing is nice, right? Because you can even test on, if you have some custom hardware with a weird protocol, you can write a console implementation for that. You don't have to use VNC, but it's the easy path. But we're going to need to define a graphical console. And for that, we're going to look in the distribution object. So some of the names used for things in ISO to video are a little bit overloaded, let's say. The distribution object, think of it as where you define how the system under test is going to work. So in this case, we're defining how a Linux system works. It has a virt.io terminal, and we could define the 9 virtual terminals here. If we were testing a Windows system, we define something totally different. And you can also put different hooks so that you can test different distributions. This is the original plan. So when SUSE run their massive test suite, they can run it against all different varieties of OpenSUSE and SUSE Enterprise products and so on by changing stuff in the distribution object. We just need to, look, I already did it. We need to add this line to define a virt, a VNC console. And then we're going to modify the test to run a frame buffer test command and capture a screenshot. So I think I prepared this earlier so that I don't have to... Oh yeah, I just have to... What do I need to do to get this back? I need to git stash. Right. And then I edit my test. Okay, so here's one I prepared earlier. Important that we're going to run this shell command on the virt.io terminal, and it's going to write to the frame buffer. And then we're going to save a screenshot of what's on the screen. Another important thing, ISO to video is faster than you. So when you run a command like this, it completes in a few milliseconds. But actually, this takes microseconds. So this screenshot's going to be blank. And there's an art to GUI testing of adding the right timeouts. Here we're going to say, wait until the screen stops changing for at least 1 second. So as long as this completes in less than 1 second, then we know we'll get a screenshot of once this command is finished. Or if this takes more than 1 second, then we'd get a black screenshot here as well. So there's an art to knowing what's a reasonable timeout, but it's fairly easy once you get used to it. Okay, let me run this test. It's taking a little bit longer. We look at the magic results file again. Okay, succeeded. That's good. In 6 seconds. And we have a couple more details entries here. So instead of being text files, these test steps are screenshots. And if I open one of them. So this is the first screenshot, and it's blank. But what's in the second screenshot? Good news. Good news, we got a test message. Oh, I switched to the first one. Hopefully it's big enough to read it. So that's our first graphical test. But it's not really a test, is it? Because if I change the text or if the program breaks, we're still going to get a screenshot that we have to review manually. So the last thing I want to talk about is making assertions about the screen. When you write a test, you make assertions. Like the main thing is do something, then assert that the expected thing happened. And the openQA test API has a bunch of primitives for that. So I said already, think of openQA tests as like a DSL, and no internet, so I can't show you. But I promise you that this link has full documentation of the test API. And the assert screen is one of the test functions you're going to be using a lot if you do graphical testing. So assert screen takes a needle tag, and a timeout, which raises the question, if this is your first openQA talk, what is a needle? So a needle, very simple, it's a reference screenshot with some JSON metadata. This is an example from the GNOME OS tests. And the screenshot defines one or more match areas. Okay, so we're going to make a needle. But I'm going to go a little bit into how to do good GUI testing. This is very important if you're going to make graphical tests, right? Because if you did this the dumb way, and you go, okay, I've got a reference screenshot, I'm going to test every pixel against every other pixel, what happens? Bad things, yeah. It breaks, right? It turns out that graphics in GNOME change quite a lot. Like the font rendering changes regularly. You don't notice because it's very subtle, but the exact pixels change every so often. The rendering changes slightly. The colors, the gray color is a slightly different gray color tomorrow. Or maybe the design team decided that the high contrast option should be below the on-off shapes option. Or maybe something in settings changes. Well, this used to say activities, right? The clock, right? The clock is different every time you run the test. So you don't want to compare the whole screen. What you want to do is make your test work like a human. So if I'm a human, right? If you say, turn on the high contrast, what I do is I don't start here in the top left corner. I visually scan the display for something that says high contrast. I go, okay, here it is. And I don't care about every pixel. I just care, okay, does it say high contrast? Yes. Where do I click? Okay, here's a switch looking thing, so I'll click on that. So to make good tests that don't break, you need to make really targeted match areas. And say you want to click the high contrast button, you just match this text, and you just match this switch. And nothing else, right? Because nothing else affects, if the font rendering changes, the test should still pass. It's not a bug, unless you're trying to test fonts. So let me show you how to do a fairly simple test in the minimal test I've been using as a demo. And to do this, we need to create our first needle. I prepared one earlier. So, to show you, there's a screenshot, and here's the needle. So it has a tag. You can have multiple needles with the same tag, which lets you cover like 3 different versions of the same thing. We only have one here, but we could add more. And this is our only match area, which is where we expect the text to be. Another important thing is the match percentage. So the way ISO to video works is it searches the whole screen for anything that matches the region you defined. And it gives the match a score from 0 to 100. So you can play with that and decide how exactly you want it to match. 90 to 100 is a good usual sort of default. And we're going to play with it a bit and see how it works. So let me go back into the minimal test. First, I'm going to add an assert screen call. And I'm going to set the timeout to 1 second. That's all we need to do. Do we think this is going to pass? Yeah, I hope it's going to pass. So let's add a couple of failures as well and see what happens. How could we make this fail? So this FB test string command, these are the XY coordinates. This is a message, and these are the colors. So we could make some changes to some of these. Okay. Let's change. I don't remember the color codes, but let's change. Let's do a subtle change. This one's the background, and this one's the foreground. So we'll do it like this. And then a couple of others. Let's, change the location. Okay, so maybe 800 won't work because the screen's not that big. Let's put it 400, 200. And then last one we'll change the text. I'll change the message and see what happens. Everything is political. Okay, so this is going to take a bit longer because we got 5 different tests. And let me see. First, we're going to look at the results. I need to give this a big screen. How are we going to make this work? Right, because we need to look at the test at the same time, don't we? So, I'm in a different directory now. Okay. Never do live demos, is my advice. Okay, so the first test, we expected it to succeed. And that would be... you know what happened? It exited at the first failing test. So we're going to see... There's the first one, which passed. And then the second one will have failed. So I'll show you those two. So the first one is number 9. I need to get the details object and then get number 9. Okay, and we got a bit of new metadata here. We got, there's one match area. The similarity was 100% because it was the same thing, right, as the reference screenshot. And then here's the screenshot here. And right, out, test results, minimal 10. Okay, so the screenshot was what we expected. Now let's look at the second one. So that was, I think that was number 12. That's number 11. Was that number 13? Okay, it was number 13. So here, see, it matched at a different place. Probably didn't match at all and got 0 similarity. So the screenshot's minimal 14. Test results, minimal 14. I didn't want to view it that way. Okay. And it didn't match because it was blue. Okay. Let's try. How am I doing for time, by the way? Okay, because there is a couple more things to go through. So let me show you. I'll delete the one that failed. We'll go through these ones. And yeah, I missed the time warning. I was getting so interested in testing. Okay. All right. Well, hopefully I've shown how. I'll go to the end now. We've seen how needles work. Unfortunately, we're not going to get to running GNOME OS, I think, given the time constraints. But I have good news that we're going to talk more about this in a talk tomorrow. So maybe we'll have to start the talk a little bit earlier. But imagine we replace the GNOME OS, the minimal VM, with a GNOME OS VM, and we can do exactly the same kind of screenshot matching. We can run apps, and we can actually overlay builds of apps as well. So I was hoping to tell you about all of this, but tomorrow we will do it. So the important thing I want to cover is how can we use this? And the fact is we need sponsors. At the moment, GNOME's openQA tests are running on the GitLab CI runners, which doesn't work great for running VMs. It can be pretty unreliable. So we need some sponsorship for ongoing infrastructure, even just one machine where we can run VMs. And there's also nobody full-time maintaining the tests. I haven't had any funding to work on this in a long time. All this has been done in my free time. And I don't think anyone else in GNOME is getting funding to work on this stuff either. We got a little bit of investment from the STF project last year, but no one does this for fun, right? Testing isn't something you do on your holiday. It's not something you do on your weekend. So until there's funding or until there's people being paid to work on this stuff, it's going to stay in the current state. It's going to stay as kind of a kit of parts that you can use to do what you want, but without much more than that. And trying to build more of a community around this, we now have a matrix room, which is testing.gnome.org. And we have a monthly call where we meet up with people from different distros that do QA and talk about what's new in the world. So the next call is Thursday, the 5th of August at 3 o'clock, UTC. Everyone's invited. And the details are in this GitHub repo. The call's going quite well. It's had people from Fedora, from Debian, from OpenSUSE, people that work on openQA itself, people from GNOME, people from KubesOS and more. So we now have a space to talk about this stuff, and hopefully we'll get on to the next steps. So thanks for watching. Thanks for staying a little bit later and seeing right to the end. Thanks for everyone that's been helping to make the tests work. And yeah, thanks for watching.
Thank you, Sam. Any questions in the room? Oh, I would like.
I'll repeat the question. It's okay. Yeah. Okay. Yeah, the question is if it's only for virtual machines or if you can run it on bare metal. And the answer is it does have multiple backends and you can run it on bare metal. The catch is you get to kind of do it yourself. So you have to write the commands that integrate with the bare metal. And you can either you have to first boot it and then set up the VNC connection, or you need another approach. If you're interested in doing this, the KubesOS people have made the most progress. So Marek from KubesOS has tests running on bare metal with openQA. So if you're interested, we can talk in the QA call as well. Any other questions? Okay. Great.
I like it from the pressure for your a question from an external point of view. Why not rely on the application unit testing suite? So if I run, for example, Firefox, the program should have a suite.
Yeah, that's a good question. So the question is, why not rely on the unit tests of the application? And the answer is you need to do both, right? We think of it as like a pyramid, where at the bottom you have lots of unit tests covering individual bits of functionality. And then at the top you have a very few tests with something like openQA that test the really hard to integrate stuff. Because like GDM is a good example, right? GDM has unit tests, but they can't cover almost any of the difficult code paths because it's doing difficult stuff and it integrates with lots of system components. So yeah, openQA shouldn't be the first thing you use to write tests. It should be the last thing you use to write tests. It should be the thing where you go, okay, I've written tests for 50% of my application, and the other 50%, it's impossible to test. I have to test it manually. And that's where you can start looking at openQA. I think Federico has a talk, actually, on other ways to test this afternoon, so that will be a good one. Okay, right, thanks a lot.
For everyone watching online, we are going to have only one talk now at the first track, so please go ahead and watch our first track YouTube stream. If you have questions, I invite you all to join the chats as always. Thank you and see you later.
How late was last night?
Blah, blah, blah.
Can you try to upload your presentation? I have no audio here. Just a moment.
Okay, are we live already?
Yes, we're live.
Okay, I have returned. I can hear myself coming back. It's fixed now. Thank you very much. All right, are we ready to start?
Yes.
All right. Benvenuto. Hello, everybody. My name is Juan Pablo Ugarte. I'm from Argentina. I'm currently living in the US. Let's see. Okay. So today we're going to talk about Cambalache. So Cambalache, it's a new tool I started a few years ago after working for a very long time on Glade, being first one developer, adding new features, fixing a lot of bugs, and then becoming the only maintainer for the past few years, trying to keep it up to date, doing my best in my free time. I decided it was no longer worth trying to port it to GTK4, that instead we needed something new, fresh from the start, trying to avoid some of the major design flaws that Glade had. So I'm very sorry I couldn't be there in person. Unfortunately, a few days ago, me and my whole family got the flu. I'm much better now, but obviously I couldn't travel. So I hope I will see you next year. Okay, so Cambalache, the name. It's something that any person from Argentina or really South America will immediately recognize. It means junk job or its window or basically anything, something when something is messy. And that's what it felt developing Glay and trying to come up with a better way to implement it. It meant that I needed to do a lot of different things that seemed like a mess in my mind. And it's also a very famous tango by Enrique Di Cepolo, and you can then download the slides and watch the video. So yeah, I think, and you'll see later in the slide, I think the name might even help one contributor do something for us. All right, so Cambalache 1.0. So what was the factor deciding when Cambalache can make the first release? Basically, it's a vague goal. It's having enough feature, having the application working well enough where I could say, please stop using Glay. You can now use Cambalache even for your GTK3 project, and obviously for your GTK project, the GTK4 project too. But obviously, one of the main design goals was to make it as stable as possible. Okay, so the broad design goals were not to use the runtime objects, that means the widget you are creating as the data model itself. Use something separate. I already explained this in more details in my previous talk, so I'm not gonna go through much detail, but originally Glade used the actual widget. When you created a window, it will create the actual window, and the data model where it stored everything was the actual window. So that worked well in the beginning, but then things started to get added to the type system. Just keep in mind, Glade was started even before GObject existed. So then, for example, my example that I always give is when we had to add support for construct-only objects, or construct-only properties. Now you have your data model that you need to recreate every time you change a property. And that complicates things a lot, especially you need to keep all the hierarchy intact and put things back together. It gets complicated quite easy. Another thing that I really wanted to have is the workspace widget. I wanted to have them in a separate process. So the widget you are editing, just for preview purpose, I want them in a separate process just to make sure that anything that widget does, let's say that you set a property to the wrong value and the widget decides to call abort, I didn't want to abort the whole application, but only the previews. I also wanted to make sure that the whole workflow in Cambalache is around using templates, that it's easy to create your own template and use it in your project. And I decided I wasn't gonna reinvent the wheel with the UI, and I was just gonna, in the first stage, I was just gonna copy the UA of Glade, and once I had basically all the other goals reached, then I will start thinking about how to improve the actual UI to make it more usable. Okay, so for the first, I'm also not gonna go through much detail here. For the data model, for the first goal, what I decided to do was simply use SQLite, model the whole type system and the whole project as a regular database application. That's why there are a lot of base type tables where I describe all the type system. You have a type, properties, signals Then the project tables, where it's your UIs, your objects, your properties you set in that object. All that data, the type, property, and signals, that's all populated by catalogs. Those catalogs are created by a simple script I made that's called Cambalache catalog gen. It's a Python script, takes data from the object introspection data and also some data from the actual runtime. It compiles everything into a file, and then it has all the hats you can imagine, and then Cambalache simply only loads the data. For the workspace, the widgets that you are editing, that you are creating, are instantiated by a different process called Merengue. That process communicates with Cambalache using JSON for commands through a Unix socket. And in the beginning, I showed the widget using the Broadway backend and a WebKit web view. That's how the first few years Cambalache show your widgets using a web view. And I think it was last year, I made the change to a custom Wayland compositor. It's a small widget that I wrote using WL rules library that basically just show whatever clients want to in a GTK4 widget. And okay, so before we start with that, I want to give some special thanks first to Valpacket for adding DMA buff support to Casilda, which is the library for the Wayland compositor widget. Drew Bob for a great tip about using Wayland socket instead of Wayland display. Few Jaco and Kishimizu for their great shaders that I took from shader.com for the presentation. So the DMA support by Valpacket. This is, I think she's from Argentina and probably saw Cambalache and realized, oh, who made this? Probably somebody from Argentina. And she added support for DMA buff. In the first version I made was all software based, so it was using shared memory, and the clients, Merengue, will render using the Cairo backend. And now you can see here, this is the compositor example. It's running inside GTK demo. And if I go here to the inspector, you'll see that right now it's using the GL render. Thanks to Valpacket. Right. Yes, that's the link for her cool website. You can check out all the different projects she works on. So Drew Bold made a comment in Mastodon when I presented Casilda, the first version, and he said that, hey, why don't you use Wayland socket to connect directly instead of using a regular file socket? I didn't knew about the Wayland socket, so I investigated a little bit more in the past few months. And I decided to add a couple of new functions to the API. One is to get a client socket file descriptor. It just returns you a socket already connected to the compositor. So all you have to do is spawn your process, pass that descriptor, and use it, set it in as the Wayland socket environment for the child to pick it up and use it as the connection. I also added a convenience function that basically spawns a command, a process, and does all the setup of the environment for you, creates the socket and set the environment, and runs the application. So all you have to do if you want to create, if you want to show a process embedded in your application is you create a new compositor, you pack it wherever you want, and then you can use this function to spawn an application and show the window inside. All right, so small window management improvements. In the beginning, the window management was very crude. All windows started in position 0, 0. So right now, one of the improvements is that when you start a new window, it starts in center. Transients for windows or parent windows, let's say that we open an about, now the order is enforced. So before if you click here, it will bring the window on top, and there was no way to go back to the child window. Now the order is kept, and I also took the opportunity just to tint a little bit the parent window that is not receiving any input. The other thing that I did is if you have a window that it's maximized and you resize the compositor widget, it will resize the maximized window for you automatically. So that will allow you to embed any out-of-process window quite seamless in your application. I think with this, it should be enough to basically replace the GTK3, GTK plug and socket widgets that only worked on X11. Okay, so the original widget used some utility functions from WL roots to render the whole scene. So it will use a WL function to grab the window from every client connection and composite one image, including the background. And that's what I use in the render method, just to snapshot that texture that contains all the other windows. But that means that the background is not rendered by GTK, so you can change it with CSS. As you can see here in this example, in this screenshot, I set everything to red and only the header bar changed, not the background of the compositor. So that's another thing that I changed lately. So right now, the compositor is using native GTK rendering. It's creating a texture from the client's DMA buff window. And for each window, I'm just calling snapshot. I'm using the damage region. So that means that the background is not rendered by WL roots anymore. So it's rendered by GTK. So now you can do things like, if I open the inspector here and I go to the CSS and then enable this, you can basically change the background with CSS. All right. And the other thing that I want to show here, if we go to global, let's see, settings, and show the graphic updates. And here you can see that only the parts that change are updated. Let's see where we have the GL shader here. You can see only the things that change are updated. close that and continue. So what's missing for Casilda 1.0? I think I might deprecate the background color property. We don't need anymore. I need to decide whether to deprecate it or re-implement it using CSS. And maybe bump the library version to 1.0. If I remove the color, I will bump it to 1.0. So it's a new library version. And then what's next after for the following things? One thing that I would like to do maybe is implement the scrollable interface so that, let's say that you are here and you want to move this, you move this window to the side. I would like scroll bar to appear here automatically so that you don't lose, like, let's say now yours make your compositor smaller, then you lost the window because the position is off screen or off widget. But if I implement a scrollable, then you will be able to just scroll back and grab the window back and move it some other place. So that's one thing that could be improved. Then keyboard layout. Currently, clients in the compositor only see the default US layout or the default layout that you already. I'm not sure exactly, but I think there needs more work to be done to support switching layouts and other layouts other than the default. And there's a new Wayland extension about Windows session management that at some point I would like to make sure that the compositor supports so that it remembers all the position of your windows. Okay, so going back to the main topic, Cambalache. What's new since the last GUADEC? The first major thing is accessibility support, not on the application itself, which is not accessible. It needs a lot of work, especially because of the compositor. I need to see how to expose that. And also, I never had time trying to figure out how to make such a big and complex application accessible. But that's something that I plan to do after the release of 1.0. So accessible support, let's say we have a small window with only two widgets, a label and a button, and you want to make sure that this button is labeled by this label. So as you can see here, there's a new accessibility tab in the property editor where you'll see all the accessibility properties, states and relations that you can set on that widget. I set, for example, the accessibility label, which is the label that the, for example, screen reader is gonna take. It's gonna see instead of the actual label you are seeing here. Let's see, if we select a button, you can see here that it's labeled by the ID of this widget. One thing to notice, even though you're not supposed to change the role, changing the role of the accessible role change which states and relations you can set or properties you can set in a widget. All the metadata to know which states, property, relations can be set depending on the role. It's taken directly from the specs. The Cambalache catalog downloads the specs HTML and then parses that and extract all that data and store it in the catalog for Cambalache to consume. So that's all handled automatically. If something gets added there and there's a new state or relation, all I need to do is rerun that script. When I generate the GTK catalog, it will get updated automatically. So that's all for accessibility support. I also added G-resource support. So now, let's say you have your UI with a window, but you also want to edit your G-resource files. You can go here in Add, and you can add a new resource, and this will create the G-resource for you. Let's add a resource with a prefix. GUADEC, and inside let's put a couple of files. And select some UI file, and then you can change properties, and it will automatically create the XML for you. Not that creating this XML is complicated or anything. This was added mostly because now that the project has that data that knows your G resource, I can improve the workspace. So for example, if you add an image here, then Cambalache will know exactly when you use a resource path in the preview, it will know how to get to the actual file and show the actual file instead of just showing a broken image icon. So that was the actual goal, but it's also nice to be able to see and make small changes easily to your resources. So internal children. So this is not used much in GTK4 anymore, but it was plenty used in GTK3. And one of the biggest users probably of Glade, and now I think they're starting to move to Cambalache, is LibreOffice. They have a lot of dialogues implemented in Builder. So they use they use Glade for editing those dialogues. And internal children are children exposed. So you can see here, for example, GTK3 dialog has a vertical box and an action area. Makes this bigger. Here, that's the action area, and let's show the XML generated by Cambalache. So if you can see here, it's the dialog. If you set any property on an internal child or add something inside the internal child, let's say I'm going to add this spacing here, Cambalache will automatically create all the internal widgets for you. So it will declare the vertical box and inside the action area and set the property. If you don't change anything, then nothing will be changed. So that's the basic support for internal children. Please, if you see anything that's not working or that it's missing, because I need to declare manually which widget has which internal child. So if something is missing, it's because we just need to add the metadata, please file bug. Okay, another big change is regarding the project format. Initially, the project format was one big XML with SQLite table dumps inside. So the project contained the data for all the UIs you were editing in the project, and you needed to export to create the XML. I made this because in the beginning, Cambalache didn't support most of the feature of GTK Builder, and I didn't want to give the user the impression that they could just open any XML and store directly the changes there because I didn't want to lose any data, any data that wasn't supported by Cambalache. So that's why I wanted to have an explicit action made by the user to import the UI and then explicitly export when the user wants. I have changed that, so now it's more, I simplified this. So now I'm not using the data model in the project anymore. It's simply a reference to the actual UI file, and each time you save a project, it will save the UI file to the latest, and it will always use the UI file. So in theory, you could manually go and change the UI file, and Cambalache will pick up the change. Only the hash will fail. Currently, I'm only printing a message into the console saying that there was a mismatch in the hash, and that's all. And for projects that you didn't specify a file yet, I simply embed the content of the file inside the project. So let's say, okay, let me say your name Martin, and it's been a long time you haven't done any change in Flatsil, and you want to make a silly change to the UI. So what you're seeing here, this is the directory structure of Flatsil repository. You can see here in source directory has widgets. Inside the widget, you have your about dialog app info viewer. So let's say you want to edit this project. It has a lot of different templates. So what will you do is create a new project, set it, let's say that we want to save that in the source directory of the project, and we're going to name it GUADEC test. Okay, you create a project, and now it's empty. It created a UI for you. We don't need this, so we're gonna remove it. And now you can do is just import a directory. Select which directory you want to import. So it's the source directory here. Click import, and Cambalache will automatically scan the directory, find all the different files that it supports, and load them automatically and show them here using the directory structure. So you can see here, this bigger. You can see here that in the source directory we have a style file. There's some resources files that we can edit, and a widget directory with the about dialog and all the widgets that you see here in the tree. So you can come here and make a change quite easily, and when you save, it will save the UI file directly. And this is how the Flatsil Cambalache project looks like. You can see here there's just a reference to the resources, CSS, and UI templates, and things like that. All right, so widget catalog. What about if you want to load if you have a custom library that you use in multiple projects? What about if you want to load those widgets in Cambalache? So this format is still not final. It's still a database dump. This is the file created by Cambalache catalog gen. It's using the guild data. Those catalogs are Cambalache look for them in all the data layers inside Cambalache catalogs, in where you install Cambalache, and also in your home directory in .cambalache/catalogs. It will look for all those files and load them in topological order. Let's say that your catalog depends on GTK4, it will make sure that GTK4 is loaded first. So this is how it currently looks like. This is a catalog for a small library that I made for this talk with a couple of widgets. And this was generated with this command. This command was always used for development only, so it needs a lot of work to make it more simple, but basically here you can specify that it should target GTK4. You declare which are the dependencies of this catalog. Currently it's only GTK4. Where the gear is located for your library, which external catalog it should depend on, and this is used mostly for property types. So my widgets use properties that are defined in GIO or Bixpath and also in GTK, and which types I want to export, and that's all. Then all you have to do is just copy the catalog in a place where Cambalache will pick it up, and you have available all those widgets. So what I'm going to show you now is how we can use those widgets. Here you say we have a talk compositor, a shader toy, and a source view. So if I go here, what you're seeing here is this is Cambalache running the talk that we are seeing. And this is a custom widget that's present in the talk. So if you go here, you can see all the different widgets that are defined in that catalog. And that's how I made this presentation. Okay, another thing that I added support for is Blueprint. For people that doesn't know, Blueprint, it's a different way of writing your UI file. Instead of writing XML, which nobody should be writing XML by hand. That's why I believe that so strongly that I made a whole application so that I don't have to write XML by hand. I think XML is just a computer format. The fact that it's text, it's only good, in my point of view, it's only good for debugging. You should only read XML if you are debugging something, but never on your regular workflow. So if you wanna don't use XML, you can use Blueprint, which is much nicer way of writing the UI. For example, this is the XML for a window with a header bar and one button inside. If you want to use Blueprint instead, you can select your UI, and here in format, just choose Blueprint instead, and Cambalache will use the Blueprint format for that UI file. And you can still edit, say button, you want to go and change something, it will change. And the only thing you have to keep in mind, if you're also going to edit this file, if some user are going to edit this file manually, is that Cambalache orders signals, properties, everything that could have an order, it's ordered alphabetically. So if your file, if you edit something manually and you don't put it in the right order, the next time you save it on Cambalache, it will change the order. That, of course, can be fixed by keeping the order of every property in the data model, but currently it's not a priority. Eventually, I might consider doing it. Okay, so notifications. Some people, if you are using Cambalache, might notice that you get a notification when when a new release is made. So I made this notification system not only to notify you when the new version is, but I also wanted to have a way to connect with Cambalache users and try to create a community. And for example, I made a notification, I sent a notification to Cambalache users about this talk. And here now I'm going to show you all the different types of notifications that it currently supports. So let's say this is connected to a local development backend, and this is the small tool I made to control that backend. So let's say this is the metadata I have for the current release. Let's say that we want to make a new release to this 1.0.0. So I will change all the metadata here. Save it, and then once a day, when your application pulls if there's any notification, it will get that there's a new version, and it will show to you here. I can also send messages. This is the way how I notify about this talk. And all I have to do here is save the message and then publish it, and it should appear here as a message. And it also supports.
We have 5 minutes left.
Are we on time? Okay,
Yeah.
I'm wrapping up. So, yeah, thank you. I haven't done yet any pulls, but you will get pulling, so you will be able to choose your option in the pool there. So what's missing for 1.0? Really, the only thing missing that I want to add before releasing the first stable release is GTK expression support. I didn't finish this because I spent too much time working on Casilda and making the new rendering thing. And also, now that I have the new project and the new workflow, I can finally finish writing documentation, taking big screenshot and not making the documentation obsolete before finishing it. So what next? What's the things after 1.0? Well, once we cover this, it will support most of the GTK builder features, so we can start improving the user experience, like adding drag and drop support or improving the object editor, which currently is auto-generated. My idea is that the user should be able to edit the object editor in Cambalache itself if it wants to change something out in different order, and just save it in its user directory, and it should have its own editor as you want. So as usual, help wanted. If you want to help or have any question, please join us in the Matrix channel, open issues in GitLab. And I don't know if we have time for any question.
Does anyone have any questions? Yeah.
Hi Juan, congratulations for your project. I want
you.
to ask, I've seen from a speech of yesterday that the Broadway backend is deprecated. Is it safe to assume that you are targeting Wayland only? Thank you.
Yeah, I don't use Broadway anymore for embedding. So before it was used to show the widgets that you are editing embedded in the window. I don't use that anymore. I use Wayland now, but the application can be run anywhere. Like you can still run Cambalache in X11, and internally Cambalache will use Wayland to communicate with the widget. But you can still run it in any backend. It's not a requirement to use Wayland for the main application. It's just the protocol used internally. I don't know if that answered your question.
Yeah, yes. Okay, so I don't think we have any more questions in the chat. So yeah, thank you for your talk, Juan, and yeah.
All right. Thank you guys for coming, everyone in person and online.
Thank you.
you just go ahead.
So, hi, am I heard? Yeah? Hi. So yeah, I'm Carlos Garnacho, and I'm going to talk about, maybe supporting TVs and smart TVs and whatnot with the GNOME platform. So my motivations are that smart TVs are becoming really ubiquitous. I might argue that they are becoming the third big platform after computers and mobile. They are still at an early stage that not all applications are that much useful, and there's that much quite a lot of crap between some gold nuggets in the smart TVs application markets. But they are essentially computers, and they are becoming the third big computing platform that exists in virtually every home. So it might make sense to support it. But they are a privacy nightmare. All the ad support, all the internet connection required for everything all the time and whatnot, it does not make it an attractive platform from our perspective, like free software developers and appreciating freedom and whatnot. So yeah, there might be some room for something that is more privacy aware and whatnot. And they are also a security liability because these platforms, they are basically supported by their own brands, which maintain these operating systems for TVs, but they don't have to be supported forever. And at some point, like this. So yeah. So they are a security liability because these brands and these companies, they are not maintaining everything forever, and at some point you will have a device in your living room that is not maintained anymore, and that's basically a security nightmare in that regard, because a device exposed to the internet with no updates and whatnot, it's not a really good path forward. And they are also closed platform with walled gardens, as in, you don't have any control on it. People make applications for LG or Samsung and whatnot, and it has to go to those specific markets, places, but you have to target a very specific device and support that, and that's not what we are going to do, obviously. So free software and privacy-aware solutions are needed. We appreciate freedom, as I said, and it would be nice to have something that is friendlier to our philosophies and everything. There are existing solutions, like Kodi is very well-known project, and there's this LibreLec being basically the horse battle, like their GNOME OS, kinda. But we have a very versatile stack, and we have plenty of things that we have many of the pieces that can build a proper platform for these devices. And we like open computing platforms, and we know how to do free software. Attention slide. So what is HDMI-CEC? The CIC thing stands for Consumer Electronics Control, which is, well, known with many brand names. As I said, this is a very disaggregated market, and not every brand will call it the same, but it is basically the same standard. And it is basically a messaging bus between all the devices that are connected to a TV through a HDMI cable. As in, yeah, you plug a DVD player or a Blu-ray player or a console or an audio system or things like that, and everything you can control it through this messaging bus. And basically, these devices can request to be the active sources, and they can make everything switch, so you can switch to that. And when you turn on the console, the TV switches, it is this mechanism. And it also features remote control pass-through, so you can actually control these things with the TV remote. And the TV is the controller of this small network, and you can basically control it through the remote control, even if it's insufficient in places. But yeah, these are the limitations of the platform, basically. Downside is that it needs hardware prepared for it. As far as I understand, this consumer electronics control goes through a specific pin in the HDMI cable, and not every manufacturer of GPUs and everything and laptops, and they basically chip out and they don't support this because why would they? Devices that are prepared are the Raspberry Pi. This is actually has built-in support for HDMI-CEC, and yeah, you don't need that many things. You plug a Raspberry Pi to the TV, and then you are able to control it with the remote control. And for these cases that there's no proper hardware support, there's the Pulse 8 adapter. This is a manufacturer brand that they basically did this adapter where you plug the HDMI cable from the TV, and then you get a regular video signal from the HDMI cable, and then the SEC bits through the USB cable, and you connect both to your computer, and then you get image and control with the remote. Yeah, so the consumer electronics control, as described by the Linux documentation in the kernel, is, well, it is not really hopeful, but there's still some nice things that we can do. Yeah, there's quite a few things that it allows to do, and some are more attractive to us, some less. But obviously, it will allow to change the routing. As I said, you can request to be the active source, and the TV will switch to that and make it work. Also across HDMI switches and everything, you might have a whole hierarchy of devices connected, and everything should redirect to the proper thing with this messaging. You get, as I said, remote control events when you request to be the active source, and the TV will send these remote key codes and whatnot. Well, key codes. It will be sent to your device, so you can control things. You can control the audio return channel, or whatever its ARC stands for. So you can have actually a soundbar plugged to your TV, and we can turn it on or off, which is, this might be kind of attractive to us, so like being able to control these other devices in these conditions. You can change the volume of the TV, which might not be as attractive to us because, yeah, changing the volume from two places might not give the right result. Like if you raise the volume in the in the laptop and at the same time on the TV, you might get like everything going up too fast or going down too fast. So this might not be as attractive to us. You can control the power state of the whole system and ask for things to be turned off when you enter standby, or ask for things to be turned on when you turn on. So we can make things just work if we want so. You can also set an on-screen display on the TV so it shows something. This is kind of a gimmick, I'd say, but yeah, it's supported, so yeah. You can change and set timers, like programming some other device to record from the TV or things like that, which is, again, not as much desirable to us, but it's supported. And there's a whole lot of small things that, as the Linux documentation said, it's a mix of high-level and low-level things that have a subset that might be interesting to us, and the rest, yeah, it's there, but we don't have to touch it, basically. With TV remote control, it very much depends on the manufacturer and the brand, on what kind of control does it allow you to do. Like, not every button in the TV remote might be forwarded to the application or to the computer. But basic navigation is it is pretty much a must. Every brand will support this, and yeah, basic navigation like up, down, left, right, and select and back, so you can navigate some UI. You have the media actions, like playing and stopping, or moving to the next track, or whatever, or video, or something. There's this set of colored buttons in TV remotes. I don't know how did they agree to that. Seems miraculous to me, but yeah, they all have this. So this usually allow these quick actions that are not that much used, but well, yeah, they might be available for us. They usually are available in these devices, so we can make use of that. If you are in increasing degrees of luckiness, you might have a numeric pad, and that might allow some things, typing numbers or kind of doing the old way, the old mobile phone way to type things. This is, yeah, we should not be relying on this, basically. And an input method working on that, it might be very cumbersome, and it might only suit for 2 people in my age bracket, so that might not be that interesting. You might have access to pagination, like being able to move, and not up, down, but page up, page down, which might be really interesting, but not every brand forwards this, so that is very unfortunate. And then you have a whole swathe of buttons that might be given to you, but might not, and they are not that much, might not be that much useful to us, but that we could still do some things with them if they were there. So that this might be on a case-by-case basis, but might be interesting to support anyways, even so they might not work on every device. And how about integrating SEC in the GNOME stack? This is what I've been mostly working on. I've got so far some supporting matter. I have not push a branch yet. I would have liked to do that, but I didn't have time to do that. And I have not mentioned about these different roles that you might take in this HDMI-CEC network, where you might be, well, the TV is in control of all the network, but then you can have playback devices or record devices or audio devices and things like that. I think the playback role is the most suitable to be a third party, to something that connects to the TV and shows something. I think that it is the most suitable role. So that's what I've done. The next thing would be handling these TV remote events in Clutter, like converting them to a specific set of events that are not keyboard events, because it's similar, but it's not the same, and it makes sense to keep the distinction and maybe make a joint thing together in the upper layers, but in the lower layers it makes sense to keep things separate. And obviously propagating this all along, so all the UI bits can do something, or we can propagate them to clients. And I have not done much about this, but we should consider how these events should be treated. Some things make sense in a Wayland protocol, for example, navigation and whatnot. They do make sense to forward to the application, to the client that is currently in focus, and be handled by them directly, like not sending like a high-level hint and whatnot. But for other things like media and whatnot, we have MPRE, which might be a suitable way to forward media keys and whatnot, so the application can pause or reproduce or jump to the next track or whatever without that much implication from the application. We already have that, so it might make sense to just forward these media keys that way. And we also have GSD media keys and these things, for example, these blue, red, yellow, green buttons, we could handle them in GSD media keys so they can launch something in the high level without forwarding them to the application. So there is different treatments that these events might want to get, and we just need to think about what we want and where. And there's obviously other possibilities for exploration, like turning on the audio bars and whatnot when you switch to that. So if you play a movie, the audio bar turns itself on, and you get to enjoy the experience without having to turn on everything yourself. I've seen some obstacles, the most obvious approach to handle this. There is a library which is called libsec, but it is very high level, and it doesn't allow you to forward, to give it a file descriptor and get something from it, so you can get this stream of events from the file descriptor. You must rely on it. It's got too much wisdom, past wisdom about these strange kind of devices and past devices that they need this special treatment, and this library it smoothens the surface, so you don't have to deal with that many hardware details, and that is nice. But yeah, the downside is that you cannot just give it a file descriptor and have it do things for you. So the next stop would be the kernel APIs. That's what my approach is doing, essentially. And over there, you can obviously handle things through a file descriptor and just get things I've still yet to see how does this behave with the. I don't have a very wide sample of devices to try with, so people might be finding trouble, and we might be needing some corner cases to handle some devices. But yeah, we'll see. But this is what I'm doing now. Like my Matter branch is using the kernel APIs to handle these events directly without any other layers. The next obstacle, after having something that works on of this, is that login does not forward devices with the SEC UDEP tag. This should be easy to handle. Like it's just telling it to forward another set of tags together with KMS and input and whatnot. So, and I think it makes sense. It shouldn't be that much controversial because it's already in the same domain than the other UDEP tags. So that might be made to work. Next downside is that these SEC file descriptors and whatnot, they are obviously not HID nor UDEP. No. Yeah, these are not regular input devices, so we cannot revoke them the permissions. Well, for example, when you switch TTY, you might want to revoke the access to the previous instance and grant it to the other. So this might be an obstacle, and this requires kernel work. And as far as I know, nobody did it yet, but it should be possible at some point. Yeah, so the next bit might be the WLAN integration. As I said, yeah, the clients might want to handle these events, and this will require a WLAN protocol. This protocol, in my opinion, should be mostly oriented to handling input. And if we want something for the clients to do things with the other higher level features of the protocol, it might be ideal to handle it in a separate protocol or in separate protocols. So the basic thing is input, and I think it should be separate from the rest of the use cases. And the protocol, if it's oriented like that, it shouldn't be that much hard or that much complex. Like you just need focus semantics and button press semantics and button release semantics. You don't need a lot of messaging to make it work. And everything else should ideally happen through other means. And have the compositor involved in how these things should happen, as in, okay, thanks. Yeah, and I covered that a little bit later, but I think these protocols should also be generic to cover infrared devices. Same thing with remotes and whatnot, but it might be nice to make it generic with infrared. The next step would be integration in GTK, which needs a sensible UI navigation with this kind of events, like moving left and you focus the widget on the left or things like that. And obviously, this navigation should be consistent, and it shouldn't get you stuck in places in the UI and whatnot. You should be able to navigate all the UI with these basic commands. But the good news is that this is a shared goal with accessibility, because yeah, accessibility does very much require sensible navigation driven by keyboards and whatnot. So we might have a lot of that groundwork already done just because we need to handle accessibility. And yeah, as an implementation detail, we might need a GTK event controller that is separate from input from keyboards and whatnot to handle this. Or it could be an event controller that does handle focus and navigation for keyboards as well as remotes. That's up for exploration. And talking a bit about the form factor of the TV, yeah, this might not be the thing that GNOME shell is designed for. We would like to focus on full screen applications, and we have an interface where navigation is a really strong user pattern and input is very limited. So, for example, the on-screen keyboard is actually mandatory, and it should be keyboard navigatable, and you should be able to control for these few places where you might ideally want to have some keyboard input. And yeah, the options are, there are several options to handle this. Like we could have a special compositor designed for this, or we might extend the kiosk in order to handle this use case, or we might have a special GNOME shell mode to just seamlessly switch to this case. And as I said, the ideal application is extremely light on input. You don't want to be asking for input for keystrokes or letters or things like that. You should be able to navigate mostly all the way to wherever you want. So a good ecosystem would be, well, disgracefully, yeah, we have to handle these things that people might want. So web applications to handle these providers, these media providers that we all know. I'm not going to mention them, but yeah, it might be nice for the user to support them, and web applications might be a way to do that. We might need proper media viewers that are more oriented to navigation rather than having you go to the file browser and having you look for some file. We might have media viewers that handle media in the local network, and we have already libraries for that, and they are very much underused, and we should be able to support them properly. And this might be the excuse for the return of content apps because, yeah, as I said, navigation is very strong. You don't need that much input, or you shouldn't require that much input. So it's would be ideal that everything is already there for you, and you just navigate through the content and don't have to type what you want or look for things. And so far, I've talked about well, supporting this stack in devices like the Raspberry Pi, devices that are a slave, sorry for the word, but for the TV, so a secondary device for the TV. But if we wanted to run the GNOME platform in the TV, the role that it should be taken in this SEC network, it should be different. It shouldn't be playback, it should be the TV. And it would handle input differently. And this is where the generic protocol would pan out. Yeah, you could get infrared input directly, and actually we would be the TV role, and we would propagate these events from infrared via the SEC channel to these other devices. So the role that we take as a secondary device or as a TV, that is completely different. But yeah, well, what are the chances that this happens? Yeah, you might root your device. I think some there was this website like Root My LG for LG TVs, where you can root your device and do things with it. I have not tried it, but yeah, it might be a possibility for some devices. The second would be waiting for vendor buy-in. This is not impossible. I've seen it happening a few times with mobile already on GNOME, but the chances are extremely low. We shouldn't be hoping for that or rooting for that. But anyways, it doesn't have to happen all at once. The walk has to be walked, and having a good start might be already an attractive point to start with the other things and get that vendor buy-in when we get some proper support and things like that. So it doesn't have to happen everything at once. And last, well, this effort will need your help. Like my area of interest and the itch I'm trying to scratch is fairly narrow and very sharp pointed. So yeah, I would prefer to rely on some more effort other than mine in getting this done. So if this raised your, made your imagination fly or things like that, please reach to me and we can make it happen. But yeah, just don't expect me doing everything I've talked here about. And yeah, this is all I had. Thank you. So, any questions? No.
So thanks for your talk. And as you said, that the Raspberry Pi is the only, like, or one of the platforms which is like quite well supported by us, but also like in the Linux space, especially for the kernel bits part. Did you consider talking to them because they might be interested in getting that going to some level?
So I'll be honest, no. This is in very early stages, and yeah, but it is actually, it makes complete sense. If we are going to push for it, it would make complete sense to coordinate with the Raspberry Pi people in this. And no.
So after stripping out the media controls and the colored buttons, you're basically left with navigation and pagination, if I got that correctly?
So yes, that is the most common set of buttons that these TV manufacturers will give to you. So the other things are in the standing rank of likelihood, so we might not be able to rely on them, basically.
Yeah, so the question is, why do we need a separate input protocol? Does the application really care whether, I mean, if it's just navigation and pagination, that's just a keyboard stuff. Why does the application, I mean, I can see the compositor maybe would be interested in knowing if it's a remote or if it's a keyboard, but does the application really need to know?
Yeah, I think this is mostly about Wayland philosophy, as in one of the big failures of X11 was trying to make everything a pointer or a keyboard. And there are many devices that don't quite fit in that thing. And I tend to think that a TV remote is not quite a keyboard. So it might make sense to reunite the use case in the upper layers, but have the protocol be still separate and whatnot. That's what I think makes most sense from a Wayland protocol perspective, basically.
So about the protocol, we also kind of have the similar input mechanism with game controllers, right? Like they can be really complex, but you can always dumb them down to exactly the thing that you have on those remote controls. So that's one of the things that I wanted for a long time, and we never got. But like I think the KDE folks already have this working, and that would be kind of nice to maybe look into how they're doing this, and maybe also look into like a protocol that supports both of those use cases, because I think that would be kind of amazing if we could like unify the game, like a simple version of the game controllers for navigating UIs, and like the remote control stuff.
Yeah, so game controllers are indeed a complex use case, because you might want to forward the full thing to games, but yeah. So so game controllers, you might want to forward the full thing to games and still have some basic navigation from the simple client perspective. It might be reunite, I don't know what KDE did around this, but might be worth a look. Yeah, sure.
Like you mentioned, they're basically supporting only like simple buttons, but newer remote are actually quite complex. So if you want to unite all those, sometimes they offer like even touchpads or like controllers like the game controllers, which have different like analog support for. So is that still going through the same protocol in case, or?
Yeah, that is an actually good question, because there is these TV remotes that allow you to point to things, and they have analog things, but I have no idea, to be honest, if there is any of that is forwarded through this consumer electronics control thing. Yeah. Yeah, exactly. No, if GNOME, the GNOME platform was running in the TV, we would get all the control of all of that. Yeah, exactly. You jumped a few chapters ahead. Sorry. So, any more questions? Yeah. So, thanks for coming, and I guess. Thanks.
Thank you for the talk. And Yeah, I was going in a loop. Now I think it's okay.
It's all good.
Yeah, I think it is supposed to be like that or like this.
Yeah, I mean, we can open the presentation once.
Yeah.
Yeah.
Okay.
Yeah. And we can start in like 1-2 minutes.
No, it's starting in 10 minutes.
I'm starting in 10 minutes.
Yeah, 3:25. 3:25, then... Wait. This is just a break. Yeah. Oh, there's no break in the
Cazzo, perché il tuo schermo non si vede, cos'è che...
Penso che tra l'altro sia già partita la testsuite, non c'è il blocco di... c'è la schermata di tutti i quindi non ti risposto lì per questo motivo, ma in realtà funziona molto bene. devo avvicinarmelo. Quindi.
Perché non ho capito cosa hai detto oggi. Ieri, anche se parlavi qui, si sentiva.
Incredibile.
Oggi per qualche motivo...
1, 2. Così non si sente.
Prova.
Ok.
Welcome back from the coffee break. I leave you with Domenico with...
Unlocking modern window management in GNOME with Tiny Shell.
Good luck.
All right, so good afternoon, thank you. And so yeah, my name is Domenico Ferraro, and today we are gonna talk about window management in GNOME by using my open source software, Tiny Shell. So let me introduce myself. I'm Domenico, and I'm Italian. But I currently live in Madrid, since I work there as a software engineer at Amazon. And yeah, I'm the creator of Tiny Shell. So what is Tiny Shell? It is a GNOME extension, which has the goal to bring for everybody some advanced and modern window management. The idea is to achieve that with like three major features, major steps. Improve the existing features that GNOME already has, or implement features that GNOME actually is already missing. And moreover, to bring the best features that you can find in other Linux desktop environments, other operating systems. So I built Tiny Shell actually 1 year ago. So it is written in TypeScript, and during this period, it has gained some traction and some popularities with more than 1,000 stars, 1,000 downloads, whatever. And the GNOME support is from GNOME 42 to GNOME 48. And I have this personal goal to extend and guarantee to every users down to 42, up to latest versions, all the fixes, all the features that are upcoming. All right, so let's have a look at a very easy use case. You have 3 windows. You didn't do any kind of window management. And this is the kind of chaos you may end up with. And like when I say no window management, I say like you are not even doing using the functionalities that already GNOME has. So we can actually use one of the main functionalities that GNOME provides, which is edge tiling, to move out from that chaos. Okay, at least we all know it's live. Okay, so you grab your window, you move to the side, and you put the window to the second half. But then we have 2 windows. We want them in a corner, and this is not really supported as of today. So you need to move manually and you also need to resize manually. So yeah, this is error prone, but most importantly, this is a little bit time consuming, and think about doing it every day is very time consuming. With Tiny Shell, oh, that's nice. Okay. Thank you to the Italian connection. As I said, I'm coming from Madrid, so I didn't expect this to happen, but still proud of my country. Wow. Yeah, thank you. What's going on? Let's try. Okay, thank you. Okay, I accept the terms and conditions. Is Wi-Fi working to you?
Yeah. Just reload the page.
Okay.
I don't think so. Why? To get you. Actually, network manager. Why to give you lines?
Okay, I preloaded everything. Okay. So, wow, it's working. Okay, so sorry for this. And what were we saying is that with Tiny Shell, you can have also an improved edge styling. And like what we were not able to do before, to place in a corner, is instead a possibility if when you're using Tiny Shell and you enable its edge styling. So this is an example of improving a feature that is already existing in GNOME. You move the window to the quarter, and you get this preview. But if you move to the side, you can put the window to half of the screen, and you can select in the settings from which position in the screen you will trigger the quarter division or the half division. So we can move out from that chaos. Thanks also to the connection now that is working, by using Tiny Shell features, and it's not anymore error prone, not anymore time consuming. So it's just enough to grab a window, put the window to the corner, you're done. You take the second window, but we want 1/2, and it's just a matter of grabbing, moving, and leaving the grab. All right, so you can do even more with one of the latest updates of Tiny Shell, which introduces this preview, this suggestion list. So you have all other windows, and you have tiled the first one. So probably you are interested into tiling and moving from the chaos also for the other windows. And if you enable this feature, after you tile, you get the suggestions per the other tiles, for the other tiles. Those are interactive. You can click and tile, click and tile. So this is like another way to raise the bar even more when it comes to edge tiling, basically. All right, so we moved out from the chaos, creating some organization, but what organization really means? In TileShell, it means dividing the screen into a layout, and the layout is made of multiple tiles. For example, made of 3 tiles, the ones that I'm highlighting here. So what you do with TileShell is a multitude of features, but behind the scenes, there is a wall layout system that enables all the features that I'm gonna show you and that you are already seen. For example, what we did with edge tiling before, TileShell did the quarter division, so I was using the layout that I'm showing here on the screen. And the layout system, I want to also introduce to you the rest of the layout system, which is this list here, which is the TileShell menu. You'll find all your layouts, and the first 4 are the built-in ones, but you can create new ones, remove the existing ones, edit, you have freedom here. And for example, the last one is highlighted because it's the one that I have selected, so the active one. And it's something that I have created. And if you have multiple monitors, you have different visualization. Like per monitor, you get a different list. This allows you to select different layout per monitor, and you can also select different layout per workspace. So again, under the flexibility in this. When I said before to bring features from other operating systems, I also meant about the Snap Assistant, especially the Snap Assistant, which is borrowed from Windows 11. Yeah, I know. And so you move the window to the top, the Snap Assistant will show up with all your layouts. All the tiles are interactive. You get a visualization of what is the effect of your action if you leave the window on a tile. So you leave the window there, and the window moves to that tile. So we spoke about tiles. Let's speak about tiling system. It's another way to create organization moving out from chaos that TileShell is providing. A little bit borrowed from Windows 11 and other solutions in other operating systems and desktop environments. So you grab a window and you press the activation key to enable the tiling system. So let's grab it, but beforehand, let's activate a layout. So here I activated the quarter division 1, and you grab, activate, and leave. And then if you want to span multiple tiles, because you want, for example, a half, you can do this. I'll show you this example again, but this time, let's say we change our mind and we want to resize a window. Here is not time-consuming. It will it's flexible. You can move one window, and all the other ones will be moved automatically accordingly. So let me show you again. All right, and then we change our mind. This was challenging, I have to say. Layout editor. This was probably the feature I most loved when developing, and also challenging. You get the TileShell menu, from which you can find the Edit Layouts button, which will open this dialog here. Over there, you'll find all your layouts. If you click on them, you can edit the layout you selected. You can remove layouts, so you create or you can create a new one. So if we create a new one, we go into the layout editor. It will say to you, welcome, by showing you how to use the editor. So 3 main things to remember. Left click to split a tile, or left click plus control to split a tile in the other direction, and right click to delete a tile. It's even faster if I show you. So you press left click to split, then you can use the sliders to resize, right click to delete, and then if you want to split in the other direction, you can as well. So you may have noticed that in every demo and every picture, there were gaps, some distances between windows and the screen also. And this is another feature of TinyShell, which makes your screen with a nice look and feel, but you can set it the way you want. For example, here I prefer having 16 pixels for inner gap, or 8 pixels for an outer gap. And this is how it looks if you have my settings, which are the default ones. You can also have only inner gaps, like if you want to use the full space, or only outer gaps, or you can just say, okay, no, I don't want gaps, 0, everything, and you'll use 100% of your screen. Window menu, is a feature that is already in GNOME, which TinyShell is a little bit improving here by adding a new section here at the bottom. This menu can be opened by right-clicking on the window, and the new section includes some smart buttons. They allow you to move to the best style, rightmost style, or leftmost style. Like best style and in general, the smart behavior here is that the selected tile is chosen by TinyShell according to the current active layout and also where the other windows are. And you also get the tiling assistant at the bottom if you wanna move the window to a very specific tile, and there is a demo also for this. So the Snap Assistant is interactive, and we can move, for example, to the leftmost tile, and the window will be moved there. Window suggestion, that was a spoiler, but it can also be enabled with Snap Assistant. The goal here during development was to use less space as possible, but when showing the Windows miniatures. And at the same time, maximizing the number of rows, minimizing the number of rows by maximizing the number of windows in the same row, and at the same time looking at the actual window sizes to have miniatures that follow the same aspect ratio and proportion. Window border is something that other GNOME extensions providing window management give. So basically it's about adding a colored border around the window. And in the image I'm showing you right now is it has a border, an orange one, and it was rendered by another extension. I'm not gonna tell you which one. As you can see, there is real difficulty, it is near to the impossible for extensions to understand whether your window have bottom corners that are flat or rounded, and if all the corners are rounded or all the corners are flat, whatever. In TinyShell, which is the picture here on the right, I found a way to overcome those limitations, and TinyShell is capable to understand whether a window has a flat corner or a rounded corner. For example, this window has bottom flat corners, but top rounded ones. And other extensions also struggle a little bit on guessing the border radius, and they end up basically selecting a static and fixed value. In TinyShell instead, I wanted to raise the bar a little bit here, and TinyShell computes that value at runtime to pick a pixel perfect border radius. So there is much more, and in general, Tiling Shell can adapt to any scaling factor, or even if you are on multi-monitors setups. There is auto-tiling support, so when you open a window, that will be moved to a tile according to where the other windows are and according to the active layout. You can import and export layouts, settings for backups or sharing with friends. Key bindings there are many for many actions, like for moving, tiling, focusing windows. One of the upcoming updates will introduce the possibility to rise all the tiled windows using Alt-Tab. So this is another example of extending GNOME and GNOME already existing features. Tiling Shell will add a new entry at the end of the Alt-Tab menu. And that entry will, you will see your layout with all your windows. And if you select that entry, you can rise all those windows all together. And all the features that I show you are 100% customizable, enabled, and disabled. And yeah, so the goal here is to give you like the most flexibility as possible, and also to help you build the workflow you really want to. All right, so that was me and Tiling Shell. You can find myself on LinkedIn and GitHub with the handle domfair, and you can find Tiling Shell on GitHub as well. And thank you so much for your attention, and if you have any questions, I'm here.
Okay.
Okay, yeah, sure. Okay, I'll repeat your questions if you have any. Oh, go ahead. Yeah.
What's your wish list for window management API that the master of GNOME can provide you?
Okay, so the question is, sorry, I have to repeat the question. The question is about my wish list on Matter API when it comes to window management. So I don't really know. Like, it would be awesome to have the more flexibility when it comes to the window borders. Also to like to the sides of the window, because the sides in some cases may include also the shadow around the window. And to draw the border, to understand, for example, a pixel perfect border radius, you need to remember that there is a shadow around it, and you need to understand how much, things like that. And yeah, but I never thought about it because I just came with overcoming the limitations with my own strategy. But thank you for your question. Go ahead.
There's a question online. Does this have floating for games and stuff that does not like to be timed?
Does this floating?
Does this have floating for games and stuff that does not like to be timed?
Oh, so you can, if the game is like a window, you can actually place the window everywhere. But if it is full screen, Tiling Shell will skip that window, will not apply any window management on that window, because since it is full screen, it understands that probably you want it there and you don't want to touch it, like never. Thank you.
What about the SAS source construction? So how much memory and CPU does it use?
So from the memory point of view, the only things that are saved are like the tile where each window is. So that is very lightweight. It includes just the coordinates, so x and y, and the width and the height. For example, for the computation of the border radius, the trick is to take a little screenshot of like the left side of the window and read the pixels. So that is made behind the scenes in a async way. So that initially may take some space in memory. Does that answer your question? Or okay, thank you. Yeah, go ahead. Yeah. Yeah. I agree 100%. Yes. Completely agree. It will be also more lightweight to have the border radius. And for example, if you have other extensions that apply a border radius, that might also work if you are changing the border radius. If that works, then it's awesome. Otherwise, styling shell will read at runtime. Thank you. Go ahead.
Yeah, are there also, you mentioned before the fact of raising tiles to one tab, but are they, when you create now a tile group, let's say, is there already something which happens like you make a tile group with Firefox and Terminal, and then you switch to some other coding application, and then you raise Firefox, it will bring up all the group or only the tile?
Good question. So on Alt tab, you will see what you already see today, Firefox. So if you click on Firefox, you will open Firefox only. But at the end, you will see Firefox and the terminal all together in the tile group that you created. And only if you select that one, you will rise both the windows. Thank you. Go ahead.
This is super cool. I already installed it.
Oh, thank you so much. If you have any feedback, also share. Also bugs, no worries.
I was wondering, why did you choose to create the Unity extension, not, for example, contribute to GNOME and how it works right now?
Okay. Should I repeat the question? Should I? Yeah. Okay, so question is basically, wasn't better to contribute to GNOME instead of creating a new extension? And yeah, 100%. At that time, I bought a ultra wide some years ago, and I was struggling with management of my windows, and this was like the faster way. And I also like really wanted to play with GNOME extensions. So I initially built this extension for myself. Later on, I discovered that other people had the same issue. Yeah, also you, yeah. So you can feel the pain. And then I said, well, I already built it. Let's share with the world. And it exploded, and now it's a GNOME extension, you know? So I didn't really choose. Thank you. Go ahead.
A couple slides back,
Yeah?
there was this option in the menu of tile to the best tile. How does the extension determine which is the best tile?
Okay. So you are referring to this one, no? Okay. Yeah. So there are three options, move to best, leftmost, and rightmost, for one reason. So I initially thought about like that for myself, the best style is the one nearest to the middle of the screen. Because to me, it is easier to look at a window that is near to the screen. And that is the meaning of best style. Then later on, I understood that that was not only like, there are other people in the world that they prefer to tile from the left to the right, or to the right, from the right to the left. And that, at the end of the day, I decided also to introduce the other two smart ones. So this is the algorithm behind the scenes of the preferences. But it also works like by having a look at where the other windows are, according to your layout. So for example, if you have a layout that's just splitting in a half, and you have a window to the left, the best style will be the remaining half. Thank you. All right, so thank you so much, and I'll see you.
We have the lightning talks now in track 1. Directly, we do not have any break, so we head down there now. Thank you.
Ciao.
Ehi, ciao.
Marco. Lo sai che ci sarà un'estensione.